All right, hey you guys. Today I'm going to be talking about some advice I would give to new developers trying to enter the market. It's going to be a little bit of a longer video than usual, but I tried to be as thorough as possible. So if you're looking to get started in software development, software engineering, but you don't know where to start, hopefully this video can help you out just a little bit. Okay, so let me open up my notes. Okay, of course they're in Vim, as they should be. So let me start out with, in case you don't know, in case you're new to the channel, in case you've never seen the channel before, who am I to give this advice? I do apologize for the way I'm a little sick. I'm getting over the flu, so if I lose my voice in the middle of this, I apologize in advance. So I'm Shruti. I've been a software developer using C++ mostly as my language for 18 plus years. I've been working mostly in embedded software where we have very limited memory available to us. Yeah, and that's about really all I can say about my work, other than I'm a senior software engineer and a project manager. I started my own tech company when I was younger, and I sold it. I currently work for them now as an employee just because it's less stressful. I've mentored a lot of developers, from juniors to mid-level developers throughout the years, and I've especially enjoyed my time with some of the interns that we've had, especially the ones that are very interested and motivated for software. I enjoy mentoring them quite a bit and seeing them develop as, well, developers. And I also actively do technical interviews for the company that I work for. So I have a little bit of insight into what technical interviewers, technical hiring teams are looking for when we are talking with and interviewing a new candidate. So I want to give, also, I'm sorry if there's any jitteriness with the video. I'm still working out some issues with my Linux install and OBS and VTube Studio playing together well and not overriding my system for some reason and using all of my resources. Yeah, so I apologize in advance if there's like a lot of fan noise in the background. Some basic thoughts. I've seen a lot of people get into software development these days thinking that it's a fast track to a high-paying job, a remote job, a chill, easy job. That's not the case. Those jobs are actually a little bit rarer than you would think, and they're kind of reserved for developers that are proven in the field a little bit, that they know they can trust by having them work remote. Maybe remote isn't so hard these days, but the market is very competitive, so you have to be willing to work with the negotiations on your pay scale. If you're fresh out of university, you might struggle to get the pay that you think you're going to get going into the software development field. The opportunities are there, but you'll have to enter the field a little bit humble and ready to just get your foot in the door. Also, I think that being passionate is really required for the field. I never used to really stress this when I would talk to people about tech, but I think that's because in the past, in my experience, developers were not getting into it because of job opportunities. They were getting into it because they just love tech, and there happened to be jobs that could allow them to exercise their passions normally. So it was just the norm back in the day, at least in my experience with the people I've worked with and the time I've spent in the field. But if you're not passionate about the field, don't go into the field. Like, you're just not going to put in the work, and it's not going to be for you. It's not just a fast paycheck field. And in fact, it's extremely competitive these days. And if you're not, like, your heart isn't set on being in tech for more than just a paycheck, you're going to burn out really, really fast. So one question I get asked a lot is if you should go to university or not go to university. Maybe 5 years ago, maybe a little bit longer even, I would have said no, you could get started in the field without a university degree. But these days, that's just not the case. There's so much competition in the field that the bar of entry has raised quite a bit, and I would say a degree is more or less mandatory. There are some exceptions to this, and of course, like, there's going to be exceptions to everything that I mentioned today. But I would recommend getting a degree. Just don't get a degree to learn everything, right? You're just getting a degree to get the job because you have to check that box on the HR revision machine that they're going to use when they look at your CV, and you're going to have that degree. And assuming that you're watching this video to get started in programming, you don't have the equivalent work experience, I'm assuming, so you have to get a degree. It's important. Again, not to learn how to program. It's really just a key to open the door. But there are some things you can take advantage of while you're at university, and that's what I want to talk about next, which are the classes that I think you should absolutely take and not skip. Sadly, a lot of them are the ones that students do indeed try to skip and get out of and take alternatives for. But if that's going to be your mentality of programming, is let's take the fastest, easiest way to securing employment, you're not going to secure employment. So take every one of these courses. I highly recommend computer architecture. Most computer science programs offer computer architecture these days. Computer architecture is going to be like looking at transistors and looking at memory and how it's made, looking at CPUs and how they're made. Of course, simple ones. It's learning like how the hardware works at the level of like a transistor, right? All the way up to then like electrical signals and how that eventually gets translated into the computer. It removes the black box of computers and opens up the door for you. It's a hard class. A lot of people struggle with it, but it's also very fun. And if you can understand the material in that class, then everything in computing will open up for you. Everything will open up for you. And you won't have any fear, in my opinion, of delving into new subjects on your own because you'll have the foundations to do so. Take an operating systems class. Don't take a class that teaches you how to like write shell scripts. Like, take a class that teaches you about operating systems, that teaches you how the boot process of an operating system works, what a scheduler is, how memory paging works. Take a class that teaches you the basics of how an operating system works. I think that's essential because all the software you're going to write is going to be on some sort of an operating system. And knowing the foundations of how operating systems work are going to open up so many doors for you that otherwise would be closed if you're not getting that deep into how a computer works. Data structures courses, and this kind of goes along with algorithms and complexity because I know often universities combine those two together. I'm not the biggest fan of combining those together. I think that you should take them concurrently for sure, but they're two separate fields in my opinion. Data structures are important because it's going to teach you how, like, various ways that, well, it's in the name, like various ways that you can structure your data. You'll learn things like linked lists, you'll learn things like how the stack, how the heap works, like all of this is foundational information for computing and will be extremely helpful for you. But then the algorithms and complexity course goes right along with that because it analyzes these data structures, how these data structures can be combined together, and how efficient they are in solving problems. And at the end of the day, that's really what matters in software development, is creating the most efficient, resource-efficient software that you can, at least in most fields of software. So take these courses, don't skip them. I know they can be intimidating when you see them on a list of courses to choose, but I would highly recommend that you take them. Again, you're not going to be learning how to program at university. You're going to have to do this yourself. Like, you're going to have to build projects, you're going to have to study. We're going to talk about that later. But university is going to give you the foundation that will make you a better programmer, because deep knowledge of computing is lacking in today's job market. Let me tell you that for sure. I'm not going to go into stories, so I don't want this to become a ramble, but deep knowledge is lacking in computer software development fields these days. And if you could learn that and come to the table knowing how computers work, like, you're going to be far ahead of a lot of your competitors when you're applying for jobs. And I mean how computers work, not just like, oh, I turn on my computer, like it boots up and then I can use that. No, like, know how a computer works down to transistors, logic gates, all the way up to how the CPU is handling registers, how assembly is manipulating those registers. Like, you need to learn the whole picture. And university will give you the foundation to do that. But you're going to have to learn that on your own. You're going to really have to do a lot of self-study. Tech is a field that I think more than any other field, maybe some engineering fields, some medical fields, you really have to be a self-studier and you have to be self-motivated. No one's going to hand it to you, right? Like, even here, I can give you all these tips, I can give you resources, but you have to put in the work. All right, so the main course of things that I recommend people learn. Are these in the order that I think you should learn them? Kind of, yeah. In other cases, it's not going to be the case. But here, yeah, I think these are kind of the order you should learn things. So basic system operation, learn how the heap and the stack works, learn how memory allocation works, again, how the CPU operates. We just talked about this before. This you should get at your university. This should be something that's covered at your university, or at least you'll have access to the resources to learn about this and ask questions about this at your university. As far as what language you should learn first, for a long time, I've recommended people C++, but recently with some experience I've had talking to other developers that have also started kind of recently in the field, to be honest, I've heard some really good arguments for just learning C. I know that's like an old adage, but you should just learn C. Honestly, like it's going to teach you. Sure, you can learn everything in C and C++, but C++ has an extra level of complexity. And if you're just getting started, you want to have, and C is also complex. Let's not lie. Like C is also a complex language, but you want to have access to learn the foundations first. You have to build a foundation, and then you can put the windows and the walls and stuff, right? I don't build houses really, so I don't like the analogies aren't so great, but you need to learn something, and I recommend C, because at C, you're going to learn memory management, you're going to learn basic data structures, but you're going to have to implement a lot of basic data structures too, because C doesn't have them. Resist just downloading other people's libraries. I'll mention that later, but like, yeah, you should make your own C library, stuff like that. Like, learn C, learn how it works, because then when you get to a language like C++, which is my next recommendation, you'll have an understanding of how the things that are happening in C++ work. Like, sure, you'll have to read and study like how objects work. And if you don't know what objects are, don't worry. There's a book I'm going to recommend later that you can read for that. But yeah, like you'll have to do some research at all different steps here. Let me turn down my microphone a little bit. But you can do that research. You'll have the ability to do that research. So after C, move on to C++, because it's going to teach you the next step of abstraction, right? Because programming is all about taking various steps of abstraction from like the transistor, right? And moving all the way up. And C++ is that next level of abstraction when it introduces objects and some things like smart pointers and, well, C++ actually introduces a lot. There's a reason that it's its own language, in my opinion. And I do think that that should be your second language after you've mastered C. I have to say that with stress, mastered C. And you don't move on to the language after C++ until you've mastered C++. What does mastered mean? Mastered doesn't mean that you can solve every problem in 5 minutes. It doesn't even mean that you can solve every problem in a week. It just means that you know enough about that language that when you have a question for it, you're not going to YouTube. Don't watch YouTube. You're here on YouTube. So I mean, watch YouTube, but I watch YouTube. But like when you have a problem, go read the documentation for the language. Go see what it's telling you, how it works, because that will make you an expert in that language. That's what I mean by being an expert. Be able to really use the language. And when you don't know something, have an idea of where you might want to look to learn that thing. That's when, in my opinion, you are an expert in a language. And then Rust. This is a personal choice for me. This is my personal end goal language. Can you do everything in Rust? No. But I'm a systems programmer, and Rust is my end goal. It's also a language that's coming up in the programming world. There's a lot of hype around it. And especially if you want to get into something like embedded systems or lower level programming, I do think that Rust is going to be a big part of the future. So I would recommend that as your next step of learning a language. It's not, I mean, it is kind of like C, but it's enough difference from C that this is the point, right? Everything here has like an overall goal you're learning. C is the basics of programming and basics of computers. C++ is learning objects and abstraction. Rust is learning how to now take the theory that you've learned and apply that to another language. Because once you've done that, your language could be Java, your language could be Kotlin, your language could be any number of languages. But once you've learned the foundations, you'll see that it's very easy to pick up a new language, to pick up a new technology. And Rust is your first chance to do that because there are some unique features in Rust, like with the borrow checker and ownership, that forces you to understand something new about programming that you didn't encounter in the other language, because you're going to have that in any language that you pick up. There's going to be something it does differently, and learning how to adapt to that and then write programs following that paradigm that language has set out is not only going to teach you to adapt and learn new languages, it's also going to teach you how to recognize individual strengths and individual weaknesses in individual languages. That's a lot of individuals. and how to choose particular languages for projects, which is super important as a software developer, especially as you want to move up in your career and start designing projects. Knowing how to evaluate a language by knowing that language, knowing what it does, knowing what features it offers, can really, really help you become a better professional developer. So that's why I recommend Rust. You could place another language here. You could place Java. You could place anything. For me, that's Rust. So it's a recommendation. And then, yes, I do recommend you learn assembly. And why do I not recommend you learn assembly first? Because you're probably not going to be searching for a job that uses assembly all the time. We use assembly at work. We don't use it all the time. Now, it's possible that your passion is for a particular field of software development where assembly would be a beneficial language to learn earlier on. You'll have to make that judgment yourself. But if you don't already know that assembly is where you need to start, don't start with assembly. It's not because it's hard. It's not because it's difficult. It's because I want you to use assembly as a learning tool. I've seen a lot of developers recommend this, and I'm now including this in all of my recommendations to new developers. I want you to write programs in your language, let's say C. I want you to run it through a disassembler and use it as a way to learn what's going on in the language under the hood that you're using. I think that's extremely important for any language that's going to be compiled down to assembly. And it's a really good tool for you to have. And then, okay, of course, you can use it in other fields. Like let's say you have a security interest field and you want to maybe get into bug bounties or auditing software. Assembly is going to be something you're definitely going to want to have. So it's not a major goal to learn at first, but it's something I think you should learn as a learning tool. And of course, I mean, you can always develop things in assembly too, but use it as a learning tool. Compile programs, decompile them, and disassemble them, sorry, and then read the assembly code, figure out what's going on, learn how a loop works, learn how a variable works, learn how something is put on the stack and transferred around. Like, it will open up so much stuff. I see so many new developers struggle with things like pointers. And when you finally understand how memory is allocated at assembly level, pointers will make a lot of sense to you. Linux. I recommend it for development. I run it as a daily driver. I use Arch, by the way. I had to just throw that in there. But you should learn it for development. It's huge. It's a great tool. There's a lot of built-in tools and utilities that will make your life easier. Can you develop on Windows? Yeah, absolutely. I would say you can't develop on Windows effectively without the Windows subsystem, but the Linux subsystem for Windows. But that's a point that we can argue all day. Learn Linux. It's important. It's a really great way to develop, and it's just going to help you. It's not going to hurt you. It's going to help you. You already know how to use Windows. Learn Linux. It's another tool under your belt, even if you don't drive it every day. And then network and network programming. This is a field I see a lot of people neglecting. And then when they finally get into the real world where they have to build an actual application, and since everything these days is now online, if you don't know how networking works at a basic level, how routing works, how DNS works, how IP addresses work, and then how socket programming works, how programs interact with each other over the network, you're going to be at a huge disadvantage. So you definitely need to learn networking and network programming. You can probably take a networking class at university. Maybe I should have added that into my university notes. But you need to learn it and you need to delve into it, and you kind of need to grok it very well. You don't have to be able to set up an enterprise network, of course, but you need to understand how stuff communicates. You need to understand what's in a header file, how Git, Post, all of that works. Definitely you need to learn HTTP, HTTPS, all of that kind of stuff. Don't neglect network programming. Okay, so an aside, why not Java? So like I was mentioning, with all of the stuff we just covered, if you learn all of those foundations above, you can learn any other language, right? That's what we were expressing with learning Rust or something. And again, you could learn Java. An analogy I like to use is music. I'm a musician and I play many instruments. When I first went to university, before I decided to get my degree in philosophy, I was at the Conservatory for Music Composition. And programming is kind of like music theory and playing instruments, right? Programming theory is music theory. Instruments are programming languages. If you know music theory, you can pick up any other instrument. You just have to learn the mechanics of how that instrument works. So for instance, Some things will be quite similar, right? Like you have woodwinds. So you have C and C++. Let's call those the woodwinds. A bad example because I also have a flute included here, but C and C++, clarinet and saxophone, right? You have to mechanically learn how to do some things different. The keys are in different places. There's more keys on one than the other. You can do some things on one that you can't do on the other, but in general, they operate the same way, right? You're going to vibrate a reed, and that's going to create a sound based on how far air goes down the instrument, right? Before it starts letting some out. But then you've got languages like C and Java, and that's going to be like a trombone and a flute. That's going to be like a brass instrument and, well, I guess a woodwind instrument. They're very different in how they're played, right? But the underlying theory is the same. If you understand music theory, you understand how to read the music for that trombone, for that flute, for that clarinet, for that saxophone. You understand the basic ideas of crescendoing and then performing. But the mechanical execution is different, right? That's how I look at languages. So make sure that you take one language and really, really learn the theory of programming, one or two, like C and C++ for objects and more abstraction. And then understand that with foundational knowledge, you can pick up any other language that you want to. So why don't I recommend Java? Because Java handles a lot of stuff for you. And sure, it's easy and you can get writing programs really fast. But because it does a lot of that stuff for you, right? It manages your memory. Let's just go with the obvious. It manages your memory. It runs in a virtual machine. It's cross-platform by nature, for the most part. You don't have to learn how to do those things. You don't have to learn how to compile a program for Linux and then how to compile that same program and what changes you have to make for Windows. You don't get to learn how to manage memory. It just does it for you. And then so the first time you enter a field that you have to learn manual memory management, you're at a disadvantage. But if you go from learning all of that stuff to then Java, you just have to learn what Java does different because you already know all this foundational background knowledge. I hope that makes sense. So I recommend project-based learning as well as you study. So do these projects after you hit a point where you feel competent enough in the language to start using it. Don't get yourself stuck in like tutorial hell. In fact, I'm going to give you books to read. So don't go watch videos to learn how to program. Definitely do watch videos to learn how to program, but don't use it as your sole resource. Use it as a supplementary resource to you digging into documentation itself and digging into books and truly learning like the foundational knowledge. I keep saying that. I'm going to keep stressing it. Learn the foundational knowledge. So in C, make some things like a library, right? Make put char, print s, fprint, rewrite malloc. Learn how to do these stuff. I've watched a friend do this, and she's one of the best programmers I know because she has the foundational knowledge of how the things that are in the language that she uses mainly, she's a C developer mainly, she's written those things, so she understands how they work. She understands the quirks of how they work and why the quirks of that exist. She doesn't just read the manual, say, oh, okay, and then accepts it. She understands why that quirk exists, and that's super helpful. After writing something in C, depending on the route that you take, how early you learn assembly, I recommend that you try to write something in assembly. Just something simple, like a bootloader. Something that doesn't take a lot of assembly to get up and running, but it lets you, I guess, like wet your teeth a little bit on using something even lower than C. Just because then you can start doing what I was telling you about, where you are disassembling programs and reading assembly, and then you can learn more of what goes on under the hood. So maybe, yeah, you should learn some assembly early on after you've learned C, so you have an idea of what's happening with assembly, but don't deep dive it yet. Just learn enough to create like a basic program. After that, I recommend that you create some actual CLI applications in C. Don't worry about doing things like GUIs. Don't worry about doing anything like that at the moment. Just create a basic set of applications in C. That could be anything that you want. Like it could be a game, it could be a flashcard application, it could be a web server. You can go as complicated or as simple as you like, but make a bunch of them, put them on your GitHub. It doesn't matter if they're simple. Just make projects, work in the language, because you're going to encounter stuff that you didn't encounter in your studies, and you're going to have to solve that problem. And it's going to teach you to think like a programmer, how to research like a programmer. Yeah. And it's more moving parts than a library, right? Maybe you can even use your own library in these programs, which would be really cool if you think about it. But yeah, it's just taking, again, we're just stepping up from the ground floor, and we just keep stepping up and higher in levels of abstraction. Then I recommend that you create some GUI applications in C++. Don't neglect this. I didn't write GUI applications for the longest time because, well, my job was always being at a systems level, very low level, and we don't have GUIs there. There's not even the memory for them. But you should learn how to do this, because once you've learned how to use a framework like Qt, Qt, anything like, honestly, there's so many. I'm not going to even. There's so many of them. But once you've learned to use a framework and have it interact with the language, it's very easy to then learn other frameworks and how those interact with other languages. So don't neglect learning how to make GUI applications, but don't rush. Don't speed run GUI applications, because it's important that you have, again, all this foundational knowledge. So don't speed run GUI applications. Make some CLI applications first, but don't skip GUI applications. Finally, like, again, if your end goal is Rust, or your end goal is whatever language it is that you want to learn, create like some projects in that are more complete projects, right? This should be like, let's say, a capstone that you can really show off to employers. Don't follow tutorials for these. Make it yourself, study it yourself, learn the technologies that underlie the project. Really treat it like your first, I'm designing a project that I really want to see to completion and maybe even use. In Rust, I recommend a web server. I've seen many others recommend this as well. Take that for what you will. But this should be what consolidates all of your stuff, right? So, but also direct it a little bit towards what you want your end goal to be, because by now you have enough knowledge of programming that you should be able to kind of know where maybe you want your niche to end up. So have this project be based around that niche. Maybe it's going to be more like a desktop application. That's fine too. But definitely have some kind of a capstone project. Okay, so there's some other technologies that I highly recommend that you learn. The first one that I recommend that you learn from the get-go, almost maybe before you start programming, is Git. You need to learn version control. It's going to save you so many headaches, so many nights crying in your bed, eating ice cream with your cat because you've completely destroyed your project. Learn version control and learn all of Git. I know some people recommend that you just learn the basics, like what you're going to need as a developer. No, learn everything. Really learn and understand what's happening with Git and version control. It won't take you that long. It'll take you maybe a week. If you study it regularly, practice using it, it can even happen less than that, to be honest. But you need to learn Git inside and out. You need to understand what everything is going on when it does it. It's just going to help you. It's going to set you aside as a professional developer. Jira. Jira sucks, but we all use it, or we use some form of Jira, like some form of project management software. When you get a job, you're gonna have to use project management software. Unless you're really lucky, maybe then you won't have to use it. But most of us have to use it, and learning how to use it is super helpful for distinguishing yourself as a developer. My recommendation for you, I'm just gonna say, because I'm gonna recommend some books and stuff too. I'm not sponsored by anyone, but you can get like a personal subscription to Jira for a couple euros a month. I think it's like 12 euros a month. Use it. When you do your capstone project, yeah, it's wasted time, but use Jira to organize your capstone project. Learn how that works. Maybe even study a little bit of how Agile works. As much as we all hate Agile, it's a huge part of the field. And implement that. Develop your project in that way. It's going to feel kind of silly doing it by yourself, but it's like practicing a presentation before you give the presentation, right? You're going to know these skills, and when you go for that first internship or job, and they don't have to train you on this, maybe they have to train you on their particular way of doing it, but they don't have to train you on Jira. That's going to be something that distinguishes you from others immediately. Now, I know many people like to use IDEs. Personally, I use Rust Rover. That's like my favorite IDE that I tend to use that, or Sea Lion, or Vim. Vim is my tend to go to if I just want to pound out something really fast and get something up and running. But you need to learn how to actually compile from the command line, and how all of that works, how linking works, how creating object file. You just need to understand how compiling works, and you need to understand makefiles. Please, oh my gods, please understand makefiles. Because sure, you might say, well, but my IDE handles all my compilation for me. Yeah, on very simple projects. But as your projects grow in complexity, you're going to have to start making your own like external tools and things like in Rust Rover, so that it can run your makefile and it can do certain things that you want it to do. And you can't adjust the IDE's build process if you don't understand how the build process works at the basic level. So definitely learn how to compile from the command line. Don't skip that. You can learn it for every language, right? Sure. And at the end of the day, yes, use your IDE. It's going to be more efficient. Customize it, make it even more efficient for yourself, but know how to do it at the basic level. It's a skill that you need to have. And then a big thing that like hovers over the specter, that hovers over the field of tech. Should you use GPT, ChatGPT, other AI learning softwares? Yes, they're part of your life. They're going to be there. And that's also why you have to develop all this deep knowledge, because that's what's going to put you above somebody that they could just say, hey, ChatGPT, write me this program. If you have all this deep knowledge, that makes you more valuable. You can then use ChatGPT as a tool, like many of us do at work and in our jobs. But at this point in time, you should not be using ChatGPT to generate code for you. You should not be using ChatGPT to answer questions for you. You should be using it as a learning tool, right? So let's say you're programming something and you get stuck at a point of code. I know it can be really, really tempting to just go to ChatGPT and say, this isn't working, help me figure it out. But then you're never going to learn how to figure it out yourself. And you need to learn how to figure it out for yourself, because you're learning at this point in time. When you've got deadlines and you're pushing projects at work, and you already know that you can review the code that ChatGPT writes for you, you can make sure that it works well inside of your system, you can test it, all that kind of stuff, great, use it. But right now you're not at that point, and it's just going to shoot yourself in the foot to not just learn how to solve the problems yourself. Don't go to ChatGPT for it. But when you've solved a problem, if you want more detail into why that fix worked, you could show ChatGPT the code that wasn't working, the solution that you had, and they can kind of explain to you in more detail why that fix worked. Now, I want to put an addendum though. You should already understand why that fix worked. When something fixes it, don't just keep developing going, oh, I solved my problem, great. If you don't understand why what you did solved your problem, that's extremely important. Don't just go online and copy stuff into your program. It works amazing. Move on. Understand why. It's extremely important that you understand why, because the next time you encounter that problem, you will be able to solve that problem on your own. You'll remember how you solved it. And you'll understand maybe if there's that same problem, but a different, slightly different reason for that problem, you'll be able to troubleshoot that far easier when you have this actual knowledge. So use ChatGPT. It is honestly a glorious learning tool, but you have to use it wisely. Don't use it as a way to cripple yourself when it comes to becoming a better developer. So some general advice: program every day, even if it's just 10 minutes a day to fix a tiny little bug, or even just to write comments in your code. Interact with code every day. Make it a habit, and make sure you fill your GitHub with, even if it's the lightest green little box, fill your GitHub. Program every day. Push something every day. Don't push nonsense. Don't push nonsense. Some days you're going to need a break, so you write some comments. Fine, documentation is important, and learning how to properly write documentation is good. So if you're writing proper documentation, that's a skill that you're learning that you're going to need. But challenge yourself every day to solve something in programming. Even if it's just like a LeetCode problem, which we're going to talk about LeetCode in a little bit, just interact with programming, solve something, work on something, and document that you've worked on it. Because after a year of doing this, programming every day for a year, you will see massive improvements if you challenge yourself. If you don't challenge yourself, you're obviously just going to be at the same point you were when you started. But if you challenge yourself, you're going to really see that you grow a lot as a developer, and then you're going to build a habit as well. You need to join programmer discords. I'm going to shamelessly plug mine, where we have a lot of programmers, a lot of Rust developers, C++ developers. Join some programming communities, even if you have to go on to Reddit. Immerse yourself in the field of programming. It has to become a genuine, true interest for you. It has to become like a hobby for you. That's how you become a good developer, because then when you find challenges, you will get frustrated, but you don't just get frustrated. You actually get excited to solve the problem and understand something new about computing or a particular language or something like that. So you have to make it like your main focus and interest, right? Immerse yourself in it. Like I said here, I watch random videos about programming. I listen to music about programming. I talk with my friends about it, even if they wish I wouldn't. I have friends who are programmers. I talk to my colleagues. I mentor folks. Like, make it a part of your everyday life. You kind of have to obsess about it a little bit. You're just getting started, so you need to obsess. Put something else on hold. Don't put your family, don't put your friends, obviously don't put your social life and your support network on hold. But maybe like find a way to make it a focus in your life, especially when you're just learning. You can always pull back later, but when you're just learning, really, really obsess about it. Yeah, that's the best way I can say is make it like a part of your life. Like for me, it's like a puzzle game. If I'm going to go solve a LeetCode problem for the day, it's like, oh, nice, I get to do a puzzle. Sure, I could do a Sudoku, right? But instead, I'm going to solve a programming problem. Yes, I'm an old boomer that does the Sudoku puzzles. I'm sorry, but like, you have to have other hobbies in life. It's important. But programming also should be one of those hobbies. This is very important. I want you to find your niche. You have to think about what it is that you enjoy in programming because then you're going to do it more. But when you find what interests you, make sure you do it hardcore. Learn everything about that. Because at this point, when you're finally at the point that you're finding your niche, right? You can't find your niche if you don't know what niches exist and if you haven't tried certain ones to see if it's something that fits for you. Like recently, this is an aside, but recently I've been working on a project just because I want to learn front-end development that I'm using Rust, I'm using Attix, the web server for Rust, I'm using Terra for templates, and I'm using React for the front end. I never thought I would like front-end development, but I'm enjoying it a little bit. It's fun for a hobby for me, and I wouldn't have found that out if I didn't try it. But it's definitely not my niche. My niche is lower level embedded kind of systems programming, I guess. But it's a fun thing. And so now I know about it. I know the technologies and know how to talk with people about it, but it's not my niche. You have to find your niche. And I want you to realize, and this isn't to discourage you from going into one field or to encourage you for going into another field. It's just a realistic thing, right? So some niches are going to be more competitive than others. So if you're trying to apply for like a Java developer job, there's going to be 500 applicants to that job like in the first couple of days. But if you're applying to a systems engineer job, maybe you're going to have like 20 applicants in the same amount of time. So there's less competition numbers wise, but then you have to think it's balanced because the amount of like I can't say that you have to know more for one field than the other, but let's say for a systems developer, knowing all of that lower level stuff, all of the foundational knowledge is going to play a far bigger role. You can get started as a Java programmer a little bit faster. Now, I would recommend that you don't skip that underlying knowledge so you become a great Java programmer, but you have to find a way to really, really stand out against your other applicants when you are a Java developer. And when you are a systems developer, you really, really need to be able to demonstrate a deep, deep knowledge of computing, right? So different things will make you stand out in different niches. So what I want you to do is know your niche so well that you know what will make you stand out amongst your competitors in that particular niche. That will help you get a job, right? There's no easy route. All of the options take dedication and skill. So pick your niche on passion, but prepare based on reality. I hope that makes some sense. Okay, so some final thoughts before I get to sharing with you the reading list that I've developed. It's not in any particular order, so don't get excited. You'll have to go through it and pick pieces as you see fit. With all of the above, if you really take this advice to heart and you really do it and you really challenge yourself, you'll have the foundation to enter any form of development and to be a lovely developer, a wonderful developer. Again, you can read the notes, extra stuff. I don't want to just read to you the notes that I took. They're here just to guide the conversation. But yeah, you'll be prepared to become a developer in any field that you should want to go into. And even if you have to cross-train after you've gotten into a field and you find it's not for you, you'll have the ability to do that without it becoming a career-halting decision. You'll just have to put in a little bit of time to learn a different technology and you'll be good to go. I do want to recommend some interview prep, right? Things for that. You want to have projects. You want to have a GitHub so they can see that you're doing them. If they see that you're programming every single day on GitHub, then they know that you're not, dispassionate about the field. You're going to have no problem showing up to work and programming too because you truly love doing it. I want you to contribute to projects as well. I know it can be intimidating to open up another person's code base and be like, oh my gosh, what do I do here? Where do I even start? You know what though? That's what's going to happen when you get a job. You're going to enter a job. There's going to be an already existing code base in 99% of the situations, and you're going to have to read that code base, understand how it works, and then start developing in it. So if you can join some open source projects and demonstrate that you already know how to do that, that's going to put you at a very high level compared to your competition when you're applying for jobs. So a big question. This is like another specter that's hanging over the programming field. Should I do LeetCode? The interviews are going to have LeetCode. LeetCode, LeetCode, LeetCode. Yes and no. I think that you should do them for fun. That's what I do. I'm really losing my voice here, you guys. I gotta get over this cold. Do them for fun. But you can't use LeetCode to teach you the things that you're solving in LeetCode. You have to already know things like data structures, algorithms, complexity, all of that stuff before you can delve into LeetCode. Because LeetCode is going to ask you to implement data structures and algorithms in a way that is most, efficient for, no, I'm drawing a blank, but for complexity, right? At the lowest level of complexity. That's what LeetCode is challenging you for. And you can't do that to learn how to program. You also can't memorize LeetCode solutions. Like, okay, you could, but there's a lot of them. But if you know all the underlying stuff and you're given a LeetCode problem, yeah, it might be challenging, but you'll be able to solve that LeetCode problem because you have the knowledge to solve that LeetCode problem. If you don't have the knowledge, you can't solve it, or you're just going to be looking up other people's solutions. You won't even know where to start. So it's like an end goal. It's a game. It's something to play when you're bored. It's something to push to your GitHub just so you've got something that day. Solve 5 LeetCode problems. Solve 2 LeetCode problems. Become familiar with them because companies do use them, and you do need to know how to solve problems. Even just learning how to read the LeetCode description of a problem and then know what it's asking you is a huge skill when it comes to interviewing. And then, like, this is a great situation where I would say treat GPT like a senior developer. Ask it questions that help you solve the problem, but don't use it to solve the problem for you. Here's what I mean by doing that. If you treat ChatGPT like a senior developer that you can ask questions to, like, oh, I'm thinking I might want to use this structure. What do you think about that? I'm thinking I might use this algorithm. What do you think about that? That's what you do in the real world. When you get stuck on a problem at work, you'll go to your manager, you'll go to your mid, you'll go to your senior, and you'll say, hey, I'm having trouble on this. Can you help me with this? At least if you're a good developer. If you're not, you're going to sit there silently, too embarrassed to ask questions, and you're going to hold the project up. And I would much rather have somebody that comes to me and say, hey, I don't know this 100%. Can you help me with this? Than somebody that now makes us have to work all weekend because they don't have the base knowledge to solve these problems. So practice that mentorship relationship and becoming comfortable asking questions, but not for solutions, asking for like clarifying questions. Learn how to do that. Use LeetCode for that. So now some book recommendations. You're going to have to pause this. You're going to have to write these down. I can see if I can put this in the description, but it's very long. I don't want to read all of them to you. You'll be able to go through them and kind of see the general gist of what they are. But if you read all of these books, it's quite a long list. So if you read all of these books, and there are a lot of them, so it's going to take you probably more than a year to read through these, right? You'll have, I'd say above an academic, probably above a master's level understanding of programming. Some ones I really want to point out that I find very helpful are these ones by Tannenbaum and other authors. They are great if you want to get into systems programming. It's just amazing. Computing systems, that's going to teach you like the architecture stuff as well as like binary, all of that kind of stuff. That's really good. Maybe we will just go through these real quick. That's a very good one. The Art of Software Security Assessment. Now, I've included this one at the recommendation of a programmer friend that I know that she's a very good developer. This is going to help you when you develop software, thinking about developing secure software, because believe it or not, that's definitely something you're going to need to do in today's day and age. Software needs to be secure. Everything's connected to the network. But it's also like kind of a look into software analysis and maybe a way to not get those NAs on HackerOne and get some negative points. But I would definitely say this is a book worth reading. Design Patterns by the Gang of Four. That's what GOF stands for. If you search this, you'll find it, no problem. It's a little dated. There's new methods of handling this stuff, but it's going to teach you the basics, like, again, the foundational tools of object-oriented abstraction and programming. Use it for that. Read through it. Learn how, what they were thinking when they were writing the book. And then it'll give you the tools to then walk into other object-oriented programming environments and kind of understand what's going on. Programming Principles and Practice Using C++. This is written by the writer of the language, Stroustrup. I don't know if I pronounced his name right. It's a great programming resource. If you want a book that's just going to walk you through not just how to program in C++, but give you a strong foundation in how to program in general, this is a great book. Once you've learned C, this should be your next book, because some of it's going to be revision for you, and some of it's really going to be new, but it'll help you step into that new world of object-oriented abstraction. Compilers, I've misspelled principles, techniques, and tools. It is what it is. It's going to teach you about compilers. It's going to teach you how they work. It's going to teach you to write them. It's going to teach you everything about, that you need to know, in my opinion, about compilers to be a developer. Now, if you want to develop compilers yourself, you're going to have to read some other books. There's also crafting interpreters to learn how to do that with interpreters. This one is more of like a hands-on teaching you how to do it. I mean, this one does too, but yeah, I would recommend these books. Linux kernel development. Now, this is more like a developer's resource, not necessarily a book that you're going to want to read like cover to cover. I mean, you could by all means, but it's going to get you the basics of like how kernel works at a level of how you could interact with it and make changes to it. Not necessarily one that I would say is a must to read, but if you've got some extra time and you want to break out a big tome, this one's a fun one. This one is a necessity. Don't skip this one. In fact, I would say this one should probably be your first one that you pick up. You can read it online for free. There's plenty of PDFs for it. I personally like to have like hard copies of books. Yeah, but read this one, digest it, do every single problem in it and understand how to solve every single problem. And if you do that, and then you buy where was it? The programming principles and practices using C++, and then you do every exercise in that and you understand everything in that, you're golden. You're good. You can move on from there. This one I highly recommend. Operating systems in 3 easy pieces. Oh, I hope you can see all this behind my chair. But again, I'll try to post this in the description, or maybe I'll put it on the webpage, the shrutivtuber.com. Maybe I'll make a post that has this on there. Maybe I'll just post all of the notes on there. But yeah, operating system in 3 easy pieces. This is going to teach you everything that you really need to know about an operating system as a developer. Now, if you're going to be an operating system developer, it's a very good start. So I recommend everyone read this book. This one's going to have some people that are not happy about it, but concrete mathematics. Computers are transistors, computers work on electronics, computers work on mathematics, so you have to learn them. This is a dense book. It is a difficult book to get through. It's a dry book to get through. But if you push through it and you truly understand the stuff on it, you're going to be very, very prepared when it comes to things like computer architecture and things like that. This is another one that I just recommend that you maybe read when you have some downtime. This is a great way to practice in C and learn a little bit about the data structures and algorithms, obviously. It's an older book, but I mean, it's C. So, I mean, a book from the 70s in C is still going to be pretty helpful and usable. So I recommend working through this. This is kind of similar to the programming principles and practices using C++. Maybe it's like a little bit more, well, not towards the end. The programming and principles, it gets really advanced towards the end, but maybe this one starts off with you expecting you to know a little bit more. Like you should know how to program in C before you pick up that book. You should have at least completed this one, right? Let's see. So then there's a series of books here, which are from, I think it's No Starch Press. They're casual readers. I've read these ones when I've been on the metro going to and from different areas in my city. If I'm in a car ride with somebody, if I'm at a waiting room, I usually carry one of the No Starch Press books with me just to read something. These are great. They're fun. They'll teach you these things in a fun way. I highly recommend them. The Art of Readable Code. Your PM will thank you for reading this one, and you will thank yourself when you come back to your code 6 months later for reading this one. It's a short little quick read, and honestly, like, yeah, it just is going to help you write code in a more professional way. And then the last two deal with relational theory and database design. You're going to interact with databases as a developer. You should definitely learn SQL. You definitely need to learn how to work with that. You definitely need to learn how basic databases are designed. Do you need to become a data engineer? Not if you don't want to be a data engineer, but you do need to be familiar with these technologies. Like, it's important. So that's it, you guys. I'll scroll one time through the book list again slowly if you want to just watch on the screen and not look somewhere else or go to the website. Definitely check out the Discord if you're interested in programming and you want to learn more and you want to have like kind of a community of developers that are, most of us actually working in the field. Some are just very passionate about it. Some are students. There's a variety of people there and skill levels, which can help you get involved in different projects. And maybe you can find some people to work on projects with you, because learning to work with people is extremely important. So that was it for most of the video today. Thank you for watching. If you stayed to the end, I know we covered a lot. I know I rambled a lot, but there's It is a lot to becoming a software developer. And thank you for dealing with my frog voice since I'm dying from this flu still. If you want to watch more videos, stick around. We're going to start making some Rust videos and stuff like that. But I don't want to ramble, so come to the Discord if you want to know what's going on. Sometimes I'm on Twitch. All right, talk to you guys later. Bye. No jitters for me. Let's go. Whoa, whoa, whoa. It looks like we don't have any jitters even on the zoning thing. If we go into the city and there are jitters, that's gonna be pretty shitty. Let's go, let's go. No jitters. Whoa, no jitters. No jitters in the city for me. Whoa. No jitters in the city for me.